Hello everyone, it's Johnny again. In today's video, we are going to talk about how to get input from the users and then also the string formatting. So let's jump right into it. First thing is, how do we get input from the user? That is pretty simple. All we need to do is to type input and then inside the parentheses, type the text that you want the user to see. So let's try to execute the code. As you can see, enter your name is displaying in front of the prompt, which is waiting for the users to enter an input. I'm going to type Johnny and then press enter. Now let's check the data type of the variable name and then also print out the value of variable name. As you can see, the variable name is a string data type and then it has a value of Johnny now. Here is another example where I'm asking the users to enter their age. So let's just pretend I'm still 18 years old and press enter. If we check the data type of age and then the value of age, you can see that the data type is string and then the value is 18. Now because whatever we enter as an input will automatically be converted to a string data type. If you want to do some mathematical operations, you need to make sure that you convert the string to integer or float data type before we do any mathematical operations. I'm having an example over here where I'm asking a user to enter two numbers x1 and x2. So let's execute the code. It is asking me to enter the first number, so I'm just going to randomly choose a number, let's say 13.45, and then enter the second number. I'm just going to say 65.43. Now if we print out simply x1 plus x2, you'll see that it is a concatenation of the two strings. It's not what we want. What we want is an addition of the two numbers, so we need to convert the first number into float and then second number into float before we do the addition. So 78.88 is the correct answer that we want. Now let's talk about string formatting. So first of all, why do we need string formatting? Let's just give an example. Let's say I want to print out an extremely long sentence, but I want to insert the name variable and the age variable inside my sentence. What I can do is use the concatenation with the plus sign. So the user's name is plus the name variable plus, and he is plus age plus years old. If we print out this sentence, you can see that the user's name is Johnny and he is 18 years old. As you can see, concatenation of strings and variables is hard to read and requires special attention on spaces. We need to make sure that we are adding adequate space in our string so that the spaces in the final sentence are correctly displayed. If we use string formatting syntax, then everything will look much more cleaner. So this is how to use a string formatting. We are just going to type the sentence as is, but then in the place where we want to insert variables, we are going to type open and close curly bracket so that indicating these two are the placeholder for the variables that we are going to insert it later. And then at the end of the string, we are going to type .format and then pass in the variables that we want to insert. Let's print out the sentence. The sentence is exactly the same as before, but then the syntax looks much cleaner. If we don't specify anything inside the placeholder, then Python will simply grab the first variables and replace the values with the position of the first placeholder and then second variable, and then insert the values to the position where the second placeholder is located. What you can also do is give an indices to your placeholders. So right now I'm saying 0 and 1 in my placeholders because in Python 0 means the first index and then 1 means the second index. So if we type 0 here, it will grab the values from the first variables, and then index 1 will grab the value from the second variables. We can execute the code here. As you can see, the sentence is the same as before. Now the benefit of using an index is because indices can be repeated. I'm having another example here where instead of one sentence, I have two sentences. The first one is the user's name is Johnny and he is 18 years old. And the second sentence is Johnny is a good man. Because the name variable is repeated twice, if we just insert an index, we don't need to specify name variable twice inside the format function at the end of the string. So that's one benefit of using index. Other than the number index, you can also use the name indices. So inside the placeholder, you give a name of your placeholder. Right here, I'm giving it a uname, which is short for username, and then user age. Then after that, inside your format function, you can just pass uname equals to the variable name, and then UH equals to the variable age. Another benefit of use string formatting is that you can actually format how you want your string to be output. Inside your placeholder, first thing you want to do is again to type the index. This can be a number index or name index, or you can actually omit it completely. But what you need to type next is a colon, which specifies that everything followed the column will be how you want your string to be formatted. Less than means that I want my string to be left aligned, and then the number 10 just means that I want to reserve 10 spaces for this placeholder. So let's see the output of these executions. As you can see, the string Johnny is left aligned with a width of 10. I'm actually printing out 1, 2, 3, 4, 5, 6, 7, 8, 8, 9, 0 just to indicate that we do have 10 spaces reserved for this string, and then it is left aligned because we are using a less than sign. It has a width of 10 because we are passing the number 10. On the other hand, the greater sign specifies that the format string to be right aligned. So it's very similar to the sentence on the top, but this time Johnny is right aligned, but it still has 10 spaces reserved for this variable. Now this pointing upward arrow just specifies that the string to be centered. So let's see the output. As you can see, Johnny is now centered around these 10 spaces. You can also specify a filling characters. What I mean by filling characters is instead of white spaces over here, you can fill it with whatever character you want. So for example, the first sentence I'm filling in with dash, and then the second sentence I'm filling in with zeros. On the third sentence, I'm filling it with asterisks. So this is what it looks like. The first sentences, whatever that's left, it will be filling with dashes. And then on the second sentence, all the white spaces will be filled with zeros. And then on the third sentence, all the white spaces will be filled with asterisks. Let's talk about sign options. If we specify a plus sign, that just means that plus sign will be printed out in front of a positive number. So right now, the first sentence, the plus sign is not to be printed out by default. I didn't specify any formatting in the first sentence. In the second sentence, I'm specifying a plus sign, meaning that, okay, I'm going to print out a plus sign in front of my positive number, which is 3.14 in this case. The white space character specifies that plus sign not to be printed out, but still want to reserve a space for the positive sign. So what does that mean? It means that, okay, in the first sentence, a white space is showing in place of the plus sign because I have a white space here in my formatting specification. In the second sentence, this is a default behavior of a positive number. So comparing the first sentence and second sentence, you can see that there is an extra space in front of this positive 3.14, and that extra space is reserved for positive sign, but we don't want the positive sign to be printed out. That's what the white space specification is doing for us. The default behavior for the negative numbers is just going to have a negative sign in front of the number. We can also specify to use a comma as a thousands separators. So just to have two sentences as example, the first one is just the default behavior when you print out a number. It doesn't have any formatting specification. The second one, we do have a formatting specification, and then the specification is a comma. So this just means that whatever number we are passing in, we will display it using thousands separator. We can also specify the number of decimal digits. So I have three examples here. The first example doesn't have any formatting, and then we are printing 19 divided by 22. So the answer is this long decimal number, 0.863636, etc. If we want to just display with 3 decimal digits, all we need to do is typing a period and then 3 afterwards. If we want to display the number with 5 decimal digits, then we just need to type a period and then number 5. So that's the output of the result. Expressing as a percentage, again we can express a number in the percentage format. So the first sentence is the original number. It doesn't have any format specification. The second sentence, we are passing this percent sign as our format specifications, and you can see that it now has a percent sign afterward, and then 0.86 is converted to 86. We can combine the percentage specification with the decimal point specifications. All we need to do is passing the decimal point specification in front of the percent sign. So right here, I'm passing in period 2, meaning that I only want 2 decimal digits to be shown, and then percent sign. And then 86.36% is the final output. We can also output our number in scientific notations. So I have a couple of examples here. The first one is just the original default output. The second sentence, we are using a lowercase e, indicating that we want the output to be printed out in the scientific notation with lowercase e. So 0.8636 becomes 8.63 e to the minus 1. E meaning that we are multiplying it by 10 raised to the minus 1th power. And then the third sentence is very similar, but instead of lowercase e, we are now using uppercase e. So the result will be an uppercase e scientific notation. Again, we can combine with the decimal specifications. So if we type period 2 in front of the uppercase e, then we will be printing out the scientific notation with 2 decimal digits with uppercase e. Lastly, we can specify any date. So to create a datetime variable, all we need to do is first import datetime, and then we can say a variable d is equals to datetime.datetime, and we just need to pass year, month, day, hour, minute, and second. Now if we printed out the variable d, you can see that it's equals to 2022 July 4th, 15 hour, which is 3 p.m., 16 minutes and 17 seconds. And the data type of the variable d is a datetime data type. If you just want to extract the individual values, for example, if you want to extract the year, you can just type d.year. Or if you want just the months, you can type d.month, etc. all the way to d.minutes and d.second. Now if we have a datetime data type and we want to print that out, there are a number of options for formatting that. First is you can format to print out your year with and without the century. So if we have a percent sign capital Y, that means that we are going to print out the year with century. If we have percent sign lowercase y, it means that we are going to print out the year without the century. So here are the examples here. For the month, there are 3 options. First option is month with 2-digit number, and we specify that by passing in percent sign lowercase m. The second example is month with full name, and that is specified by percent sign capital B. The third example is the month with abbreviated name, and that is specified by percent sign lowercase b. So here are the 3 examples down here. Also, you can specify day of the month, and that's simply %, lowercase d. You can specify weekday. So in a weekday, 0 is Sunday and 6 is Saturday. You can print out the weekday with abbreviated name, with full name, or with a single digit number. So abbreviated name is specified by % lowercase a. Full name is specified by % uppercase A, and then single digit number is specified by % lowercase w. And here are the results. For hour, you can print out hour in 24-hour clock, 12-hour clock, and you can also display whether it's PM or AM. So 24-hour clock is by uppercase H, 12-hour clock is by uppercase I, and then PM or AM is specified by lowercase p. And here are the results. For minute and seconds, you just need to use % uppercase M and % uppercase S. For day of the year and week of the year, okay, day of the year is specified by % lowercase j. Week number of the year has 2 options. The first option is to use Sunday as the first day of the week, which is specified by % uppercase u. The second option is the week number of the year, but Monday as the first day of the week, and it is specified by % uppercase w. So here are the results. After you familiar with all the formatting of a date-time data type, you can combine everything and then structure the desired format that you want. For example, in this case, I'm printing out a 4-digit year, 2-digit month, 2-digit date, 24-hour clock hour, and then minute and second. I'm using dash for connecting year, month, and date, and then I'm using colon for connecting hour, minute, and second. Another example down here is I'm printing out the full name of the weekday, and then full name of the month, and then day of the month. So here are the results, and here are the specifications that I want my string to be formatted. That's pretty much it for today's video. Let me know if you have any questions. You can leave it in the comment section below. If you like my video, make sure to like and subscribe to my channel. I'll see you next time. Thank you.